I've been working in the field of speech and language technology now for about 15 years. I started way back when it wasn't such a popular topic for people to look into, and AI was nowhere near as popular as it is nowadays. And Elena was telling me just now about some of your projects that you were working on, and unfortunately none of you chose to look into voice technology. And hopefully after this talk I can persuade you that there's lots of interesting challenges, and maybe you'll go away and think that voice is an area that you should work in the future. So voice covers quite a large range of different subjects. So first of all, I'm going to spend a little bit of time thinking, what do we mean by voice technology? So there is a dream, I think, that you can just have a conversation with a computer, just a natural conversation like you have with another person. Because this robot's typing on the web, but they can equally well talk. This is a vision which I think has been popular in sci-fi and other kinds of literature for quite a long time. Even before computers were really as popular as they are now, you've always had this image of a robot that you can talk to in sci-fi films in the past. So I didn't watch that many sci-fi films as a child, but I did read a couple of books, and I was fascinated by the fact that you could get a computer to talk to you naturally, because that seemed to me like a way out thing that nobody would ever be able to do. And I was really interested in how you could make that happen. So that was how I ended up in the beginning deciding that I would go down the route of voice technology. So voice technology now, the technology has moved on quite a lot. But imagine you are using some futuristic device like this VR headset. Your eyes are distracted, your hands, you can't see your hands. You want to be able to do stuff with this new technology. This is just one example of some kind of new technology we might see in the next few years, in the next 5 to 10 years. Voice is a really natural, easy way to interact with technology like this. To be able to say something and have it happen is a way that we find really natural and easy to do. Gesture, obviously waving your hands around, is another way that you can interact with technology like that. And I don't think the two will exist separately in the future. But for now, I'm just going to focus on the voice aspect of this. So put yourself 10 years, 20 years in the future, where you're using voice a lot more naturally to interact with computers. And you can see how far we've got to go still. So over the past 5 or 10 years, we've had a big increase in the number of voice technology applications that are out there. Having a conversation with a computer like this in order to do something is just one application of voice technology. It's the one I'm going to focus on. There are other applications you can think of. So transcribing videos, so transcribing all of YouTube, for example, so that you can search more accurately inside videos, so that you can subtitle automatically and help those who can't perhaps hear as well. Machine translation is another one. You speak and the computer speaks to someone else in a different language to help you communicate across languages. So all of these are things that we could think of voice technology being used for in the future. If you think about something like this where you're interacting with a device and you want something to happen, you want a conversation with the computer, there's a few different technologies which go into making this happen. So if you're talking to a computer, the first thing that you want to happen is that computer is going to be able to understand the words that you've spoken. So being able to go from the audio that you speak to words. And that's automatic speech recognition. The next step in a complete voice system is natural language understanding. So that's taking what you said and understanding the intent or the meaning behind those words. The next step, if you want to have longer interactions with a machine, is conversation. So you want to be able to understand sentences and put them into a conversation. The computer needs to be able to decide what to say back to you and how to react, what to do next. And the fourth thing that I think is really important in the voice technology ecosystem is text-to-speech, the voice of the device. And text-to-speech is also something which has improved massively in recent years. So I'm going to go through these and tell you a little bit about where they are now and where I see them going in the next few years. And I should say, like Elena said, I'm talking in general about voice technology here and nothing particular to do with any system, not Alexa, not Siri, not Cortana, any of those more broadly. So automatic speech recognition has been a technology it's been around for quite a long time. You take audio and get speech out. So you know a little bit about AI now. This is a supervised learning task. And what you use for training data, you have a lot of audio which has been transcribed, and you want to output the text. It might seem odd because language is a sequence, so there's lots and lots of words in the language, and actually what people say is not just one class or two classes, but almost an infinite number of classes. But we can still think of it as a supervised learning. And there's been a lot of success with deep neural networks in the past 5 years particularly in modelling acoustics of speech. And that has really led to systems which have gone from being kind of partially usable to being deployed in our big AI systems now. Now, speech recognition has improved a lot in the past few years, and what I see happening in the future is we will end up finding ways that we can build these systems on much less data, techniques that allow us to build in one language, and therefore we can easily spread out to other languages. It takes a lot of audio to train a speech recognition system right now. It takes several thousands of hours of transcribed audio. And paying someone to do that transcription for you for your particular task is quite hard. And every time you want to move from one task to another, you have to get more data that matches what you're trying to do. So reducing the data needs, letting us spread out across more domains, across more languages, is something that I think is going to come to automatic speech recognition in the next few years. The next part of a system, a voice system where you're talking to a computer, is the language understanding. So if I was to say, Alexa, play the song Frozen, it's quite obvious, you all know what that means. Alexa should start playing the song. If I was to say, Alexa, play Frozen, I want to hear Frozen. There's just so many ways of asking for that a computer has to be able to interpret and map a bunch of different ways of saying something into a single intent. And this is something which computers have got quite good at lately, is taking a number of different ways of asking for things and understanding the intent behind them. This is something which is deployed in a lot of systems right now, especially when you're doing command and control, because there's a limited number of things that you want to do. Again, it's a supervised classification task, and you're trying to understand the intent of what someone said, whether they're asking to play music, or whether they're asking for the weather, or whether they're asking to add something to their calendar, versus what we call the slots, or the entities. So if I say, play the song Frozen, or play the song Summertime, Frozen and Summertime are what we call the slot. You can change the entire utterance that you've said and interchange the song titles, the entities, and still mean the same thing, but get a different song. So language understanding systems right now are mostly trying to understand intent and slots. But of course, language is not that simple. Language is wide and varied and has a lot of complexity and nuance in it, especially once you get past these simple command and control interactions with a machine. And so I see in the next few years we'll start to understand more of the intricacies of language, more of the nuance behind it, and be able to react in different ways to much more subtle categories of things that we're asking about in computers. So language is interesting because, like I alluded to, there's almost an infinite number of sentences that you can hear. And actually, most of the sentences that you hear, you will never have heard before. It's how we learn new stuff, is to hear it from other people. So most of the sentences that you hear in your daily life are ones that you've never heard before and never will hear again. So our language understanding systems have to be able to take a limited amount of training data and generalize to language. And that is a really exciting, interesting challenge ahead of us. Of course, there's more to interacting with a machine than just understanding what someone said. Dialogue is a topic which I think is starting to become more interesting and more investigated right now. Dialogue is having a conversation between two things. So it's not just understanding what someone has just said, but understanding the entire history of what you've said to them, the whole conversation, taking what they've said and interpreting it in the conversation that you've had and in the world that you live in. So if I was to say, can you open the window? You know probably that I'm talking about one of the windows here and not a random window somewhere else. If I say, play Frozen, and I'm talking to my TV, you probably know that I'm in the film rather than the song. If I'm talking to my smart speaker, I probably mean the song. So there's all this context and all this real world understanding which has to go into dialogue systems. And right now people are thinking about two kinds of dialogue systems. two kinds of dialogue task. The first people call task-based dialogue systems. Those are the things where you want to do something particular. So you want to book a movie ticket, or you want a restaurant recommendation, or you want to know what the weather's going to be tomorrow. Those ones, you're trying to achieve something, and the computer has all the information to help you achieve that. It doesn't need so much real-world knowledge, just a database, maybe to back up your restaurant information or ticketing information. We call these task-based dialogue systems. And computers are trying to elicit from you enough information that they can do something particular for you. But of course, conversation is not just about completing tasks. We use conversation for a lot of other purposes, particularly social interactions. And there's another stream of work at the moment on long-form social interaction with computers. Actually, Amazon at the moment has a competition called the Alexa Prize. The Alexa Prize, the challenge here, is to build a bot that will let you talk for 20 minutes. I think, I'm not sure of the exact numbers, but the current bots can hold a conversation with a person for about 3 or 4 minutes, I think, something very short. So 20 minutes is quite a long way off. And if you talk to these kind of computers, you realize that they have a lot of strategies programmed into them to recover when they don't know what's going on. So they might change the subject, or they might ask you a completely different question, or they might do something unexpected, something other person would do. So dialogue is something which is definitely going to have a lot more attention in the next few years, because in order to have any more complex conversations with a computer, we're going to have to be able to understand more about how humans converse and be able to map that to how computers converse. If you know about AI, you've probably learned some things about some AI technologies. Dialogue is not a supervised learning task in the way it's set at the moment, but it's something called reinforcement learning. Have you heard of reinforcement learning? Did you mention reinforcement learning? So this is a task where you have to, instead of having an input and an output class, you have interaction over time. A dialogue is something like that, where you don't know what's the best next step to take in a dialogue. All you can do is get to the end of your dialogue and have a guess about whether you've done a good job or not, based on whether the user hangs up or walks away or gives you good or bad feedback. It's a much more challenging task, but reinforcement learning is something that is also gaining a lot of interest right now. And reinforcement learning is the basis of a lot of the current breakthroughs and the current focus of artificial general intelligence. So the idea being that in order to build a general intelligence, we need systems which are not supervised learning systems, but can actually plan and execute and learn over longer periods of time. So the final part of a voice interaction system, which if you talk to a computer, it will talk back to you, and that's text-to-speech, or TTS. Text-to-speech is also something that's been looked at for a long time and has got gradually better over the years. So when I first started working in voice technology, text-to-speech was done a lot by recording a big database of someone's speech, cutting it into small fragments, and then gluing them back together. So you would take the sentences that someone had said, and if you want to then synthesize a completely different sentence that's not in that database that someone has already said, you have to take the different sounds from different parts of that database and glue them back together. So this actually is still in use in a lot of text-to-speech systems. It's very high quality. You sometimes get little artifacts in the speech where you glue it back together, but by and large, you can start to glue longer segments together if you want to give higher quality speech. The downside, of course, is that you need a big recorded database of speech of your one person who your voice is going to be. And so you can't easily change the characteristics of that voice. You can't make it more emotional, or you can't personalize it to a different person, unless you've also got a database of the other kind of speech. People have looked into doing what I call the reverse of automatic speech recognition to generate speech. So you learn from a lot of data how people speak, and then you can slowly adapt that to different people, to different emotions, to different characteristics of voice. And so text-to-speech research right now is starting to look into how can we be more expressive, how can we be more personalized, how can we have longer speech, because if you're listening to a voice right now that's quite robotic, It's okay for short sentences, but as soon as you get into long sentences, you need to have a lot of emotion and expression behind them in order to understand what someone's even talking about. If you try and listen to a long robotic sentence, you lose the emotion and the meaning behind it. And so this, I think, is where text-to-speech is going in the next years. And so all of these technologies, if we put them together, come together to give us a system that you can talk to and can respond to you. And they've all come a long way in the past 5 years. And they've been looked at a long time before then, but particularly in the last 5 years. And that's because of advances in artificial intelligence algorithms, so deep learning particularly, and reinforcement learning have come on a long way. And they've allowed us to actually improve these systems quite a lot. The second thing that's really helped these technologies in the last year is the amount of computing power we have available. So services like AWS, Google Cloud, Azure, they allow you to rent out computing power to do what you want to do. And to have that computing power living somewhere else, you don't have to buy the computer, you can just rent it. And these mean that you can actually do a lot more, you can be a lot more flexible with what you're building. And the third thing which has really helped these technologies in recent years is data. They all need a lot of data to train them. And we are much better now at collecting and storing and sharing and accessing data. And this has enabled us to be much faster at building and iterating on these systems. So combine them together, we now have systems which you can talk to in limited capacity. But if you've used any of these systems, like Alexa, you will know that they are not perfect yet, and they still have a long way to go. So personally, I think that voice is a really exciting area because there's a huge number of challenges to go from where we are right now to where we have this vision of being able to interact naturally with a computer. And I hope that some of you will consider looking into this in more detail, and I'm happy to stick around and answer more questions.